Hello guys, this is Neha, and in today's lesson we will be discussing on subsets, proper subset, supersets, universal set and power set. Let's start with subsets. What are subsets? Let's consider two sets A and B. Set A contains the elements 1, 2, 3 and 4. Set B contains the elements 1, 2, 3, 4 and 5. Now, all the elements of set A are present in set B. So, set A is called the subset of set B, denoted using this symbol. So, set A is called the subset of set B if all the element of set A is present in set B. Now, let's consider another pair of sets, set C and set D. Set C contains the elements 8, 9 and 10. Set D contains the elements 6, 7 and 8. Now, as every element of set C is not found in set D, so set C is not a subset of set D, and we denote it as this. Now let's look at another example. Let's consider two equal sets, X and Y, with elements 1, 2, 3 and 4. From the definition of subset, we know that if every element of a set A is an element of set B, A is called the subset of B. The equal set satisfies this definition, as every element of set X is an element of set Y and vice versa. So, X is a subset of Y and Y is also a subset of X. Also, we have a thumb rule in sets that every set is a subset of itself and an empty set is a subset of every set, as empty set has no elements. Now let's see what are proper subsets and supersets. Let's consider two sets A and B. Set A contains the elements 1, 2 and 3 and set B contains the elements 1, 2, 3, 4 and 5. Now, set A is a part of set B and set B have some extra elements which are not in A. So, in this case, A is called the proper subset of B, denoted using this symbol. And B is called the superset of A, denoted using this symbol. Again, let's consider sets C and D. These two sets have exactly the same elements, 11, 22 and 33. So, set C is a subset of set D. Here, we cannot say that set C is a proper subset of set D, as both the sets have the same elements. So, set A is the proper subset of set B only if set A is contained in set B and there are some extra elements in B which are not in A. Now let's see some important subsets of the set of real numbers. Here we have the set of all natural numbers, whole numbers, integers, rational numbers and irrational numbers. So, the set of all natural number is a subset of the set of all whole numbers, as all the elements of natural numbers is present in the set of whole numbers. Also, whole number have an additional element, that is the number 0. Thus, the set of all natural number is a proper subset of the set of all whole number. Likewise, a set of all whole number is a proper subset of the set of all integers, due to the same factors, that all the elements of whole numbers are present in the set of all integers and the set of all integers have an additional element, that is, it contains the negative integers also. Similarly, the set of all integers is a proper subset of the set of all rational numbers, and the set of all rational number is a proper subset of the set of all real numbers, as well as the set of all irrational number is a proper subset of the set of all real numbers. But the set of all natural numbers is not a proper subset of the set of all irrational numbers. Let's see intervals as subsets of real numbers. Intervals are an alternative way of designating the subsets of the set of real numbers. There are three types of intervals: closed interval, open interval, and semi-open or semi-closed interval. Let's see what are closed intervals. The intervals which includes the endpoints is called the closed interval, and it is denoted as a and b closed within the square brackets. In this case, a and b are the endpoints. This interval can be written in the set builder form as the set of all x such that x is a real number and x is greater than or equal to a and less than or equal to b. Now let's see the open interval. In case of open interval, the endpoints a and b are not included in the set. Only the points between a and b belong to the open interval, and it is denoted as a comma b closed within the parenthesis. This interval can be written in set builder form as the set of all x such that x is greater than a but less than b. Now, let's see the third type of interval. These intervals are known as semi-open or semi-closed intervals, as here one of the 2 points is excluded. That is, intervals are open at one end and closed at the other end. Either end point A is included and point B is excluded, or the end point A is excluded and point B is included. Now let's discuss about the universal set. A set that contains all elements in a given context is called a universal set. Let's understand with the given 3 examples. In the first example, we have 3 sets. Set A, the set of even numbers. Set B, the set of odd numbers. Set C, the set of prime numbers. The elements of these 3 sets are also the elements of natural numbers. So, in this context, the set of natural number is the universal set. Let's move to the next example. Set V, the set of vowels. Set C, the set of consonants. Set W, the set of letters in the word alphabet. As the elements of these 3 sets are the members of the set of alphabets, so the universal set in this context would be the set of letters of the English alphabet. Now let's see the third example. X, the set of right triangles. Y, the set of isosceles triangles. Z, the set of scalene triangles. As the elements of the set X, Y and Z are the members of a common set, that is, the set of triangles. So, in this case, the universal set is the set of triangles. Let's move to the next topic, that is the power sets. The collection of all subsets of a set is called the power set. Let's consider a set A with elements 1 and 2. Now, the set A has 4 subsets. Why? As the empty set is a subset of every set. A set with the elements 1 and 2, as every set is a subset of itself. Then, we have 2 singleton sets, a set with an element 2 and a set with an element 1. These 4 subsets together form a power set. A power set is denoted as capital P and then the name of the set within parenthesis. Let's look at another example to understand it better. Here we have set B with elements A, B and C. That is 3 elements. So the power set will consist of 8 elements. We get this number using this formula. Now, the 8 subsets of set B are shown here. So the collection of all these 8 subsets will form a power set which is written here. So the collection of all subsets of a set is called the power set. So this brings us to the end of this lesson. But hold on, we have question and answers that we will discuss on the topic we have covered today. Thank you.